Assalamu alaikum. In this video we highlight the work done in the project of a human-computer interaction course. The purpose of the project is to apply HCI principles while designing an application to achieve high user satisfaction and high usability. Our application or project is called Smart Palm, and the team members are in order of appearance Hisham Al-Khuja, Abdul Latif Hadid, Muhannad Ahmad and Abdul Rahman Saad. Now to understand our application or the importance of our project, we must agree that palms are important to the Saudi economy. Therefore, our application directs palm farms problems. Nowadays, they are monitored and controlled manually except for some automated irrigation systems. So why not to think of a smarter solution? Another important or the most important aspect in palm farms is the palm infections or diseases. Many of these infections must be detected early to be treated appropriately. So we need a system that is scalable, reliable, of low cost, and provides data in real time. These requirements are the exact description of IoT solutions, and this is the reason why our solution is through IoT technologies. You might wonder where is the HCI part in all of this? Well, since the system will be handled by farmers who we expect to be not so familiar with technology, the HCI part becomes very important. We need a solution that is very simple, or a system that is very simple, very usable, and very informative, and that is achieved through applying the principles of a human-computer interaction. Now let's have a look to our system users. So we have mainly farmer and farm owner. The farmer and farm owners can do both login, sign up, and monitor Palm's data. However, the farm owner can add, edit, or delete a device. If we look into the system architecture to understand, we can see that the nodes that connect data from the Palm farm are here. They send data to the cloud through the gateways, and then the user can access these data through a web interface. The HCI part mainly handles the web interface side. Now to understand the requirements and make sure we develop the right application for users, we conducted 3 interviews. The first interview is with Professor Abdurrahman Dawood, whom is our domain expert. He's an associate professor at Department of Plant Protection in King Saud University. He's been working a lot on how to protect palm trees specifically from insects. We asked him questions to understand why would he invest in such a system, or what he expects from such system. What are the main features that must be included, and has he used any application like ours? These questions were asked on chat because Professor Abdurrahman was very busy and we had some time constraints. The second interview was conducted in the university. The interviewee is one of our colleagues who is Basel Sayed, whom we consider to be our experienced user. He worked with machine stock on an IoT project and is working on a dashboard to help in keeping track of palm trees' health. We asked him questions, similar questions to Professor Abdurrahman, but we focused on how will he be using such system and how does he imagine the app to look like. The third interviewee was Adil Abu Hamid, whom we consider to be our regular user. He's an agriculture technician who works at a local company for agriculture. We met him at Plants Nursery near the university. He's widely experienced in farm work and palm trees specifically. We focused with him on questions on how can the process of monitoring palms be easier, and how do they detect and treat palms at present, and other questions to understand their workflow and how to make their work easier. After finishing the interviews, we created an empathy map for each user and then combined them to one map. The final empathy map shows what they have said, thought, did, or felt about our system during the interviews. In summary, we saw that Professor Abdurrahman is very enthusiastic and ambitious about the technology solution. He believes that this is the best way to protect palms. Engineer Basil was also very sure that the system will be successful and will achieve its purpose. While on the other hand, Mr. Adil had his doubts that technology will be effective in detecting the infections. He also expressed his fear that such system might add complexity to his everyday tasks, and he won't be able to interact with the system easily. So this gave us an idea that different users has different ideas about our system, and we tried to conclude the main tasks that should be achieved by our system.
After collecting the user need and presenting them in an empathy map, we drew our initial understanding of what the user in their different categories are expecting the system to look like. After that, we translated the drawings to a low-fi and mid-fi prototypes and built different tasks on these prototypes. Here we have our lo-fi prototype. First, the sign-in page, the map showing the Palm trees and their status, the Palm dashboard which will display the sensor readings for the Palm, and the main dashboard of the system which will display the general status of the farm. Here we have our mid-fi prototype. It was developed using Malsmec and we can see it's more detailed and more features were added. Like, for example, we have the notification tab and the table of the nodes. For the first task, the user sign in. Then the user go to the main page, which is the farm dashboard. Then he click on the map button and he is transferred to the map showing his farm. Then he can see the different statuses of the different bounds. Then he click on one of the bounds. Then he see the dashboard of the bound. Then he click on graphs. Then he's transferred to the graphs for the different sensor readings. For the second task, the user needs to sign in. Then he's transferred to the main page. Then he clicks on the notification button and he's transferred to the notification tab. After that, he can click on one of the notifications. Then he's transferred to the details about the ban, that is the notification about. Then he can return back to the notification tab and delete one of the notifications. Then he go back to the main page, then the task.
After analyzing all the designs, we chose two designs. The first one is mobile-based application in which it is simple and you can navigate easily and you can open it easily. The second one is web-based application in which you can have as many tables as you want, as many tabs as you want, without any limitations, as in the mobile-based one. After analyzing the two designs, we choose the web-based one because it is most suitable for dashboards and you can navigate easily and you can add as many tabs as you want. Now, for the heuristic evaluation, we evaluated four tasks. The first task is add device, which is easy. The second one is check Palm status from table, which is medium. The third one is check Palm's status from map, which is also medium. The fourth one, which is check notifications, and it is complex task. Now we to evaluate, to fix and deal with all the heuristic evaluations we got. The first one we got is that the search function doesn't indicate that exactly the user is searching for using what search criteria could possibly use data besides the tree ID to search. Now we solve this one by deleting the choosing ID, and also you can search for any kind of data, like if the temperature, the moisture, or any kind of data. Now for the second problem is the graphs have no legend. The information they deliver is not clear. Now we show the types of values and in the x and y axis. So you can, as you can see, the time and the value and what is the name of the graph, which is temperature. The third problem, cannot manipulate the map. User doesn't have the ability to zoom in or scroll, possibly making it difficult to choose a specific tree. We solved this problem by using Google Map, which in this case Google Map provides you with all the utilities you need, such as zoom in, zoom out, or search, or anything. And we add keys for the map. The other problem is the login page doesn't give user the option to recover to recover their forgotten username password. In this case, we add forget password to solve this issue. The other problem also, the system should notify the user of new updates. We add notifications and we add a number beside the notification tab to indicate how many notifications are there. And the other problem, there are seems to be two sidebars instead of one. We make it one sidebar to avoid complexity. Now we have only one sidebar. It is not obvious how user would delete a notification. We add and remove all notifications, in which you can delete all the notifications, and there is also a close button beside each notification, so you can close you can delete the notifications and individually or all by one button, by using one button. Now there are some problems with severity 3 to 4 we didn't fix. The first one, regression read and recall. The data is being shown about the trees is not self-explanatory, nor it exists. This one, actually we solve it. So there are duplication. We solve part of it. There's no proof of error tracking or recognition by the static design of the application. Actually, you can, no need for error tracking because we used web application, so the user will not have any dead links or any errors. No error recovery are shown as there are no examples explaining what would happen if the user find a dead link. Actually, we don't have dead links because there are always back button, and we have breadcrumbs in which the user can navigate easily and get back where he started. The mobile version of the app doesn't seem to include notification screen. Actually, we give up the mobile app and we use now a web-based application. Now for the problems with severity 1 and 2, which are fixed. Visibility of system status, one of the notifications tells the user that there is no data coming with the problem tree, but doesn't tell him what do you do about it or the possible causes. Now we show more data, we showed more data notifications, such as the ID and to check the BAM. Match between the system and real world, names of sections, button sizes and back buttons. Now we did what we did is that we don't have a back buttons. We add a back button in the bottom of the website, and we choose the names of sections based on the standards. Consistency and standards, having the sorting function as button is unintuitive. Now we add a sort function. We add sort button in each column. So in the header of the column, you can click in the header of the column to sort the ascending order or descending order. Match between system and real world when viewing graphs for a specific tree. The tree being viewed right now is not indicated. Actually, now we have data. Now we have a page for each tree. So when you click, for example, a tree from the map or from the table, the website will show you a page with all the information, along with the data coming and all of that.
So that was our HCI project. I hope you enjoyed the video. Please don't hesitate and visit our website simply by scanning the QR barcode. Assalamu alaikum warahmatullahi wabarakatuh.